Hello there, Code Conquerors. Today we're going to dive into another juicy topic in our conquest of the JavaScript interview. I'm Luke, your host of this wonderful episode, and we've got a simple one this time, coding our way through the exciting algorithm of cumulative sums, as the thumbnail and the title might imply. It might sound like a lot of arithmetic, like I've done in my past few videos, but trust me, once we get started, you're going to see that it all adds up, if you see what I did there. Righto, so today's function is writing an function that takes an array of integers r as its argument and returns a new array whose each element, English, somebody in the comments let me know grammatically correct. I think it's whose. That's someone's possession, whose each element is the cumulative sum at each index. So let's take a look at an example of what that means. We'll get to that file I was looking at in just a second, or more like near the end of the video. At each index. So we have a function, cumulative sum, that takes an array of integers. For example, 1, 2, 3, 4, 5. Classic combination. And it should return the values of 1, 3, 6, 10, 15. So for anyone that's not following along because they've been out of a Scholastic program for quite some time, it's very simple math here, but like I said, it's not that bad. At index position 1 or 0 of our input array, we have a 1. That's as much as our bucket's been filled up. So we're going to put a 1 in the corresponding output array at index 0. At index 1, right? We have a cumulative sum of the previous index of 1 plus 2, which gets us the 3 in position 1 over here. In position 2, we have the cumulative sum of all the values, aka 1 plus 2 plus 3, which gets us 6. At position 2 in the output array, at position 3 in the output array, we get 10, which is the combination, as you can see now, of 4 plus 3, which is 7, plus 2 is 9, plus 1 is 10. And then finally, for our final spot, we got 10 plus 5, which is 15 to get our output array. We want this to make sure it works fine with negative numbers and mixed numbers. No big deal. If we get our arithmetic right, we shouldn't have to worry about too much. In this particular little example-arino we got going on. This is new compared to some of my previous videos. I do indeed, from the feedback I got in Discord from my students in our program, I need to also, granted, I doubt anyone in YouTube world out here is like, no, I don't do the extra effort to make this a repo. I would love to make this a repo on Covalence's GitHub repository, which I'll try. Once I get it up and running, I'll make a video announcing it and put it in the description below. But I want to take all these files I have and delete the solutions I have in them and write test files. So in the future, I can maybe like push an update to these repos. Y'all can pull the changes in and code along with me and be able to test it in your own terminals and things like that. So like I said, this was a idea I had that I've always done for my students at Covalence, but I wanted to make it free here on YouTube, and I want to keep on implementing. That's a portmanteau of improvising and improving, I guess. Don't worry about English. Stop it, Luke. Basically, continually improve this little free course I have here by making this into a repo anybody can clone and test themselves with to get ready for their interviews, especially as beginner students. So, yes, let's actually think about this one, and then we'll continue on with the actual code, which, as I said at the beginning, won't be all that bad. So we're going to imagine we have a row of buckets, each representing an element of the input array. So we're going to have our array as a row of buckets that are all filled with, say, apples. And as we go from left to right, aka our indexes of 0 up to length minus 1, as we go through those buckets from left to right, we're going to have a number of apples inside of them that will correspond to, again, how do you have negative apples? Stop that. Don't think about that. If these have apples in them, they will be labeled with how many apples are within. So our task is to go through each bucket and add the apples to a new row of buckets that represent the cumulative sum of apples up to that point, right? So we start with an empty basket to hold the apples. We go to the first bucket, take all the apples, put them in our basket, mark that down. Then we move to the next bucket, take all the apples from it, add them to the basket, mark that down, and continue this process until we reach the last bucket. And that's basically what I was even kind of doing by showing y'all what our input array would look like and the corresponding output. I was just kind of going down the line and tallying up every single time I've added apples to my new buckets and wrote down how many are in there each time I move along. So this may not seem very exciting arithmetic-wise, and you're already probably thinking, Luke, that sounds like it can be done with a for loop, and you are correct. So, diving on into the code here, man. We're going to have a result array that we're going to be returning, surprise, surprise, from this results. From this particular code block. We also are going to have something to track our sum as we move along. So this kind of looks like previous ones we've done. Almost like the more of these algorithms you practice, the more you're going to see patterns emerge that you have the tools in your tool belt to hammer away with. We need some kind of sum, S-O-M-E-S-U-M, English. It's the theme of this video, evidently. Get in the comments. We're going to be tracking how far along our tally goes. From there, all we need to do is write ourselves a traditional for loop. And you know, I've said this across videos. Some videos I'll write the traditional for loop syntax. Some I'll use shorthand syntax. Do what's comfortable for you. I'm just an advocate of using that shorthand syntax when it comes to whiteboard-style interviews, especially if I was in a room with people on a literal whiteboard. But in the modern era, you see a lot more remote interviews where you'll be asked to solve something like in a notepad so you don't have autocomplete features like you would from your code editors or your IDEs. So we'll start with a traditional for loop. Considering we're going through an input array, it makes sense to start at index 0. And simply continue on to the end of the for loop. What we need to do is we need to track each element of our input array and sum how large it is. At the beginning, it's 0 because we have nothing to add yet, but we're going to take the first element of the array and simply add it to our total sum. So this will take the first index of 0, aka that 1 from our input example, and add it to our sum. And hey, that's going to also be, excuse me, coming off of sickness here. Yeah, that's going to be a the same index position, 0, of our current result array with that sum. So I need to take the result array and push into it the sum as it currently stands and keep the loop going. And then from there, it's going to do exactly what that analogy with the buckets I was throwing out a moment ago is doing. It'll go to the next element, which is the 2. It will take the element 2, add it to our sum, which is currently 1, to get 3, and then push 3 into the resulting array at index 1, which is that value there, and it will continue to do so until the end of our function. Yeah, and that's all there really is to the logic that needs to occur right there as well. So we can just go ahead and give it a shot. Let's console log for visual purposes. I can now scrunch in some of the code here. Like I said, you'll see that it all adds up once we get the code going here. So we're going to console log our results together for display purposes. Let's go ahead and take cumulative sum and call it with that array. And voila, we get the output we expect. Let's try an array of negative numbers as well. Make this important. We test a couple of different potential edge cases we got going on here. Yeah, I mean, it's going to be the same thing except in the negative direction on if we had like a coordinate plane, right? And then finally, a mixed series of numbers shouldn't prove to be too difficult for this one either, which is 1, -1, 2, -2, and 3, which is correct. So yeah, it looks like this one wasn't too bad to solve. Again, I like throwing in some of these for beginners, so I don't want to always demoralize everybody the further we get in this series where they can't even pause the video and try and solve it themselves before having a result from my help. Once again, with our shorthands, we could always do something like this. And that allows us to then have it that. So, I mean, not a whole lot of additional. Yeah, we got the same output for the mixed numbers. Not a whole lot of changes going on here for the shorthand. But again, it is easier and nicer to write that. Might be a bit easier for someone that's even less experienced in JavaScript to understand what's going on here. Granted, if they're having difficulty with simple for loops, they probably have to go back to the fundamentals, which we have a course for. If you're interested in that, check out the description below. Yeah, I mean, we declare our function, we put out its arguments, we initialize that empty array for result that's going to be tracking our cumulative sums as we move along, so it's going to grow at the same length as we traverse our input array. We initialize a variable called sum that with a value of 0. That way we use it to keep track of our current tally as we move along. And then we just iterate through our input array, and every time we get an element, we add it to sum and add that to our results output array, and then we just continue on until the loop's done, and that's it. We return the array, and we can test it, and we're good to go from there. Now, there is another way we could write this. I wouldn't say it's necessarily better, or, I mean, it really depends on your user, right? So there's actually a second way we could write this that uses the array map function. So I'll go ahead and just write this cumulative 4. And then what I'm going to do is write another function called cumulativeSum that will use our alternate syntax to solve this here. This one will still do the exact same thing. We can't really get around creating our new array to track our cumulative sum and also some variable that tracks our current tally as we move along. Maybe we should call it tally instead. Whatever. So we're going to do the same thing where we have a let sum equal 0. And instead of, if you can see here, that we are taking an array, looping through the array, and returning a new array based off each element we're looping over, that sounds like an array map. And that's exactly what it is. So we're going to say return our input array as we map over each element, which we're going to call a number inside of that array. And what I'd like for you to do is take the current sum, add our number to it, and then return that sum as a new element of the array. So this is this just utilizes the exact same process we did up here, just using an array map instead, because that's what it does. The purpose is to loop through an array or map over each element of an array and modify that element in some form or fashion and return it into a new array, which is the purpose of an array map. You see it all the time in any kind of React videos. Array maps are very, very common over there. So yeah, that's another way we can solve this. If I save it, hopefully we get the same output once again. We don't, because it didn't console log anything. Haha, joke's on y'all. So if I do console log the output of this, there we go. It's the same thing. No big deal right here. So yeah, that's another way we could solve this with potentially even cleaner code. It really depends on what you like. I mean, I would say that this is pretty concise looking because we use that map function. It can be easier. It's like easier to express and easier to understand for those that are familiar with JavaScript array methods. It can be very clear what my intention and goal is here. But I will say, if you're not familiar with it, then it probably looks like gobbledygook, but that's okay. And the performance between the two, typically, your traditional for loop with some tricks is the fastest way to iterate through a large array of large array of elements. Because the additional overhead of that function, that arrow function, num fat arrow curly brace happening right there, this right here, this is additional overhead. We have to execute a function upon each iteration of our method right here. So that extra overhead could definitely means that a traditional loop is faster. But again, if performance isn't an issue, the clarity of this might be your way to go and what you might remember should you get asked a similar question at an interview spot, right? So yeah, in terms of big O notation, both these implementations have the same one. The time complexity is simply O of n, which is that linear line, meaning the bigger our input array gets, the more we have to loop over, the longer we have to loop over it, but nevertheless, we only have to loop over it once. So the big O is an O of n, that linear line. Yeah, that linear line right there. So what you saw just a moment ago at the beginning of the video is where I had this right here, and I said I'll explain this at the big end here. I'm going to translate all of my old files into folders that have an index and a test inside of it, so you could then go to your own package, like clone this project, which will happen sometime in the future. Just watch for a release video, or always check the description down below, where I'm going to have tests that can help you test yourself and try and quiz yourself to prepare for those interviews out there. So, for example, I have this test here that takes the same inputs I had in the description of our video right here. Pointing is hard. There we go. Over that stuff over there, where if I run npm run test, it should, with any luck, run the exact same tests and tell me if I pass them or not. That way you can quiz yourself either during the videos, if I'm cognizant enough to push them out first and tell you, then we establish like a new workflow of y'all pulling in the changes or the videos I add to this repo I'm going to create here, or, you just clone the whole thing and quiz yourself through and use these videos as solutions as you go through it. So, yeah, that should about wrap it up. I mean, why is something this simple kind of cool? I mean, again, like I've said in previous videos, these are all building blocks for more complex algorithms, right? Knowing how to run this logic here for cumulative sums can be really good when you're calculating more complex things like running averages or moving averages or other, like any kind of statistical stuff. This is like a good fundamental building block to get there, right? Or like preprocessing. That's a really good way to think about it as well. And being able to manipulate data, like understanding data manipulation tasks like this, cumulative sums is very useful in that as well. Processing time series data or financial data or sensor data, like if you mess with pies and things like that, where like, you're messing with sensor data, running a cumulative sum function is something very common you might do. And just your general programming skills and problem solving skills, even these basic ones, and making sure you understand how they work, can explain them via an analogy, will set you apart from somebody that just memorizes an answer and can write it out for you, but can't really explain how it works. As simple as this is, I've had many of my coding friends tell me that, being able to describe the code is a skill in and of itself as well, and not just solving what's in front of you. So, as always, thank you all for watching. I hope you found this video helpful in our cumulative journey to become better programmers and developers. If you enjoyed this video, consider giving us a thumbs up and subscribing to our channel for more videos like this. My coworker Andrew had a Code Golf one recently that was pretty dang cool. I like that a whole lot. Also, love to hear your thoughts on this algorithm in this video. If you have any suggestions, or if you got even cooler solutions, please share them in the comment section down below. Remember, constructive and positive comments are always welcome here. Let's keep this discussion going and help each other improve our coding skills. Thanks again for tuning in, and I'll see y'all in the next video.